multiplying and dividing decimals. We're going to begin with this first model. Now, this is a multiplication model. I know that because they've given me the hint here with this operation of multiplication. So, multiplying is blank, or I apologize, groups of blank. And we use of for multiplication, so groups of blank. Well, let's see how many groups there are. So I'm gonna look, I see this is one group, and I know that because it's all one color. Here's our second group. Here is our third group. Here is our fourth group. Here is our fifth group. And here is our sixth group. So we know that there are 6 groups of, let's figure out how many are in each group. Each one of these represents 100th because a whole has place for 100, and one of them there would be 1 out of 100. So let's look and see. I see if I count here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 hundredths. Here's another group of 10 hundredths. So that's 20 hundredths so far, plus this 1, 2. So that looks like that is 22 hundredths. I'm going to write that here. So let's look at this next one. This one might be a little more difficult to see, but we can use the ones next to it to help us. So this is 2 because there are 2 red here, so there must be 2 black here. This is 2 because there are 2 red here, so there must be 2 black. So looking at that, that's 4 of them. Now, let's look here. 1, 2, 3, 4, 5, 6, 7, 8. And I'm using that because I counted the reds right next to it. Well, let's look here. That's 8. 1, 2, 3, 4, 5, 6. So this is 6 hundredths. This is 8 hundredths. 6 hundredths and 8 hundredths will give me 14 hundredths. And then here I can see there's 15, 16, 17, 18 hundredths. Those are difficult to count. Plus the 4 that's here, that's also 22 hundredths. So it looks like every group has 22 hundredths, but let's count to make sure. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, let's look like every group is 22 hundredths. And if I look at this group looks exactly like this group, but it's rotated. So if I were to take this and rotate it, it would fit perfectly there. So this also has 22 hundredths. And here's our group of 10, 20, 21, 22. And then finally, this last one, we have a group of 10 because it matches perfectly with the red. Another group of 10 because it matches perfectly with that red. So that's 20, 21, 22. So this is also 22 hundredths. So we have 6 groups of 22 hundredths. So on this one, we're doing 6 times 22 hundredths. So let's see what we have. This is one whole that is completely shaded in. So I know we have at least one whole. And then this is 10, 20, 30, 31, 32. So 32 hundredths. So looking at that, we should have 6 groups of 22 hundredths is one whole and 32 hundredths. So let's show that as an algorithm. So I have 22 hundredths times 6. So I'm going to look at this algorithm and I see that I have 2 places behind the decimal. So I'm going to come over here and I'm going to write the number 2 because I have a total of 2 places behind the decimal. I'm going to do regular multiplication. So 6 times 2 is 12. So I'm going to put my 2, regroup my 1. 6 times 2 is 12, plus the 1 I regrouped is 13. And since there was nothing more for me to regroup over into the next place, I could have put that 1 there, and 6 times 0, because there's nothing there, is 0, plus the 1 I regrouped, that would be the 1 there. So, looking at it, I have 2 places behind the decimal, so I'm going to count 1 number, 2 numbers, and there's my decimal, because I should have 2 numbers behind the decimal, or to the right of the decimal. And I look at my answer and I compare, and it is the same. Go ahead and try, what's our next one to try? Go ahead, pause the video and try number 2. Pause the video at this time and try number 2. So now that you've given number 2 a try, let's go ahead and check your work. So we see that there are 1, 2, 3 groups. And I see that by a blue group, a red group, and a yellow group. So that's 3 groups. And then let's see how many are in each group. So this is 1/10 or 10 hundredths, plus that 1/2 hundredth will give me 12 hundredths in that group. Well, let's see our next one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 100 or 12 hundredths. Let's look at our third group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 hundredths as well. So this is 3 groups, 3 groups of 12 hundredths. Now let's count what we have. We have 1/10, 2/10, 3/10, and 1, 2, 3, 4, 5, 6. So I should have 3/10 and 6 hundredths, or altogether 36 hundredths. Now let's come and let's show our work for that one with plain algorithm. This is number 2. So we have 12 hundredths times 3, or 3 groups of 12 hundredths. So I'm going to go through and I'm going to count how many total places there are behind the decimal or to the right. There's 1, 2 places here. Is that it? Yep, 2 places. So now I'm going to do regular multiplication. I'm going to write this as 3 times 2 is 6. 3 times 1 is 3. We should have a total of 2 places to the right of the decimal. So 1, 2, decimal. 36 hundredths, 36 hundredths. Since there are no wholes, I can put a 0 and say I have 0 and 36 hundredths. They are both the same in value. Let's go on to number 4. So we're going to look at number 4 here. And for number 4, it is also multiplication. I know this is also multiplication because there are 2 different colors. What do I mean by that? Another way to show multiplication is to do the array method. So looking here, I'm going to see what colors come all the way down. In order for it to count, it has to go all the way down vertically. So let's look. This comes all the way down. I see that this pink is all the way down. I know you're wondering, well, what about that purple? Well, we'll get to there. So looking at this is shaded with pink as 1 whole. Let's look and see if all of this is shaded. So this is shaded all the way down. Perfect. These are great. And let me see. Oh, wait. These are not shaded all the way down, so I have to stop here. So let's count. We have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So that's 1 and 6/10. Now let's look at it going horizontally across. And remember, it has to go all the way across for it to count. So I'm looking here. These do not count because you'll see it didn't go all the way across. So I'm going to look here and I see that this goes all the way across. So for this one, it was 1/10 because I can, I apologize, I didn't mean to put that down just yet. I can see that this is 1/10 all the way across. And it also did it here as well. So this also is 1/10. Looking here, all the way across, that's another tenth. And it went all the way across here. And then let's look at this last one. This is all the way across, so that's 1/10. Let's look here. That's all the way across, so that's 1/10. It only works if it goes all the way across horizontally. So that means I'm going to take this 1 whole and I'm going to multiply it by, let's see, 1, 2, 3/10. And I'm going to take this 6/10 and I'm going to multiply it, let's see, 1, 2, 3. Also 3/10. So since they're the 1 whole and the 6/10 are both being multiplied by 3/10, I'm going to save me some space. What do I mean by that? I'm going to write this as 1 whole being multiplied by 3/10, 6/10 being multiplied by 3/10. So that's 1 whole and 6/10, and they are both being multiplied by 3/10. So now looking at this, I'm going to write down all of the places I see that are to the right of the decimal. So here's 1 digit that's to the right. Any more? Here's a second one. So there are a total of 2 places to the right of the decimal. For the 1 and 6/10, there's 1 digit to the right. And for 3/10, there's 1 digit to the right. For a total of 2 digits to the right. So now I'm just going to do our regular multiplication. 6 times 3 is 18. So I'm going to write my 8 and regroup my 1. 1 times 3 is 3. Plus that 1 regrouped is 4. So now I must I must go through and see how many places should there be to the right of the decimal. And it says there should be 2. So let's look. 1, 2, decimal. So I'm going to put this in. This is 1 and 6/10 times 3/10. And that should give us 48 hundredths. And I bet you're wondering, well, how did you know that from looking at the picture? Well, let's go and see. Remember, every one of these represents 100. So let's count how many there are. This across is 10. Here's another 10, so that's 20. Here's another 10, that's 30. 33, 36, 39, 42, 45, and 48. So that's 48 hundredths. That's written here as 48 hundredths. Go ahead and try number 8. So pause the video and try number 8. Now that you've had an opportunity to try number 8, let's check your answer. So looking here, I know this one's a little bit different, so I want to make sure you're understanding this one because you're definitely going to be able to try number 6 on your own. So let's go through and look at this. We're going to do the same thing all the way across. So looking here, I can see these go all the way across. So let's see how many there are. There's 10, 20, 30, 40, 50, 60, 70. And I know that works because each way across is 10. So there's 1, 2, 3, 4, 5, 6, 7 groups of those 10. So that's 70 hundredths or 7/10. Now let's look vertically. Nope, these don't count because they have to go from top to bottom. So that doesn't count. Oh, here we are. So let's look. Each full way across is 10. So 10, 20, 30, 40, 50. So that is 5/10, also known as 50 hundredths. So now let's look. Well, I think it'd be easier to walk around with 5 dimes instead of 50 pennies. They have the same value, but 5 dimes is so much easier to walk around with. And instead of walking around with 70 pennies, I'm going to walk around with 7 dimes. It has the same value, but it's much easier for me to walk with. And why do I pick these? Because I'd rather multiply a 1 digit times a 1 digit than to multiply a 2 digit times a 2 digit. Now, could you do that? Most definitely you can, and I'll show you that the answer will be the same. But I'm just saying, for me, my preference is a 1 digit by 1 digit. So looking at here, let's see where the colors cross. Where is it just one color? And I'll see that there's, 1, 2, 3, 4, 5. Okay, so that's a group of 5. Here's another one for a total of 10. Another one, that's 15. Another one is 20. Another one is 25. Another one is 30. And our last one is 35. So there are 35 of these little pieces. And we call those little pieces hundredths. So there are 35 hundredths. So now let's show that on our paper. We are going to have 5 tenths times 7 tenths. And we're going to count the total number of places to the right of the decimal. So this has 1 place to the right. This has 1 place to the right. That's a total of 2 places. So now let's do our regular multiplication. 7 times 5 is 35. We must have 2 places to the right of the decimal. So 1, 2, and then I can put my decimal. So we can see that it's the same. There are no whole numbers, so I can put a 0 to represent nothing there, or I can leave it blank. It is equivalent. It has the same value. Now, I know I stated, hey, it's easier to walk around with 1 or 5 dimes instead of 50 pennies and 7 dimes instead of 70 pennies, but I want you to see that the answers would be the same. So I'm going to do the same problem, but this time, instead of having 5 dimes, I'm going to have 50 pennies. And I'm going to multiply that. Instead of 7 dimes, I'm going to have 70 pennies. And now I'm going to count the total places. I see that there's 2 places to the right of this decimal, and there are 2 places to the right of this decimal, this factor. So I can see that there are 1, 2, 3, 4 places should be to the right of the decimal. So now we're going to do regular multiplication. So any number times 0 is going to be 0. So 0 times 0, that's our 0. 0 times 5, that is also a value of 0. So now let's move to the 7. I have moved a place value, so I need to make sure when I start, I am writing everything in that place value lined up. So 7 times 0 is 0. 7 times 5 is 35, so I could put my 5. Regroup my 3. There's nothing there, so my 3 is going to be there to come down by itself. Now let's look. If I have 0 and I'm adding it with nothing, it's still nothing. 0 plus 0 is 0. 5 and there's nothing to add to it. There's my 5. 3 and nothing to add to it. There's my 3. And I must make sure that there are 4 places to the right of the decimal. So 1, 2, 3, 4. Then I can put my decimal. So we can see 35 hundredths is equal to 35, or I could say it that way. It's equal to 3,510 thousandths. So looking at that, I know you're probably wondering, well, they don't look the same. Well, let's think about it. If something does not have a value there, there's nothing there. And what number do we use to represent nothing? 0. Well, looking in the next one, there's nothing there. And what number do we use to represent nothing? 0. So you can see that 35 hundredths has the same value as 3,510 thousandths. So go ahead, pause the video, and try number 6. Go ahead, pause the video and try number 6. So hopefully you've had an opportunity to work on number 6. We're going to look at that and see. This is similar to the one that we worked on for number 4. So we see that we have all of this shaded down. So I know this is one whole, and this is all shaded down for 10, 20, and that's it. So 2 tenths or 20 hundredths. Let's see what we have all the way across. We have 10, 10, and they've done it all the way across, but we didn't do it here. So this is 10, 20. So this is 2/10 or 20 hundredths. This is also being multiplied the same. So I'm taking 1 whole and I'm multiplying it by 2/10. Then I'm going to take 2/10 and multiply it by 2/10. Well, why don't we just say we're going to take 1 and 2/10, and both of these are going to be multiplied by 2/10. So I have 1 and 2/10 multiplied by 2/10. How do I know that this is the same? Well, let's look. 2/10 multiplied by 2/10. That's here. 2/10 multiplied by 2/10. And then we have 1 whole multiplied by 2/10. That's here as well. 1 whole multiplied by 2/10. So instead of me making 2 different problems, such as 1 times 2/10 and then doing 2/10 times 2/10, I just put them together and made 1 problem. Is this wrong? Of course not. But it's going to give you some extra work because all of this combines it into 1. So this is not wrong. I'm just going to utilize this one because it's much simpler to put it all together. So I'm going to count the total places. I see that this is 1 to the right of the decimal, and there's another digit to the right of the decimal for a total of 2 digits to the right of the decimal. Now I'm going to perform regular multiplication. 2 times 2 is 4. 2 times 1 is 2. And then I'm going to go through and I'm going to look to see how many places are behind the decimal. Well, great thing I did that first, and I see that there should be 2 of them. So 1 digit, 2nd digit, decimal. So our answer is 24 hundredths. So I can see here it is 1 and 2/10. And we took that and we multiplied it by 2/10. And that gave us 24 hundredths. And I know that because I can count the one that had the double color or the darker color, the different color. 10, 20, 21, 22, 23, 24. And each one of these represents 100, so there are 24 hundredths, which matches our answer. Now let's switch gears and let's start looking at the division. So let's look at number 3 for the division. Number 3 has 1 whole and 8 hundredths, and we know that because this is completely shaded in. And this one has 8 of them shaded, and remember, each one represents hundredths, so that's why we have 1 whole and 8 hundredths. And we're going to split that into 9 groups. So let's see, this is 1 group, this is our 2nd group, this is our 3rd group, 4th group, 5th group, 6th group, 7th group, 8th group, 9th group. So now let's see how many were in each group. So this is 1 whole, or I apologize, this is 1/10. So 10, 11, 12. That's 12 hundredths because each one of these represents 100. Let's look in this next group. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's another 12 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's another 12 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's looking like every group is having 12 hundredths. I'm going to count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hundredths. So when we take 1 whole and 8 hundredths and we split it into 9 equal groups, each group will have 12 hundredths. Now let's look at that on the algorithm. So we're going to take 1 whole and 8 hundredths. We're going to split that into 9 equal groups. For me, I like to write the multiplication facts off to the side. If you do not have a multiplication chart, or if you do have a multiplication chart, this is the perfect time to get that. So we're going to have 9, 18, 27, 36, sorry about that, 45, 54, 63, 72, 81, and 90. And I like to write the first 10 multiples of the number, because after that, we don't have to do any work to figure out any of the multiples because it's already done for us. What do I mean? When we use the traditional algorithm for dividing decimals, we want to make sure that our divisor, the number that we're dividing by, is a whole number. Well, since that's a whole number, I'm going to take wherever the decimal is and I'm going to pull it straight up. So now I can see I have one whole and I want to split it into 9 groups. I look on my multiples and I see that that is not possible because the first group, or I apologize, for every group to have 1 in it, I must have at least 9. And this is saying I only have 1. So I'm going to take that 1 whole and I'm going to regroup it into 10 tenths. So now I'm looking for a number that's close to 10 without going over. I can do 9. 18 is too much. So if I look at 9, 9 is the first multiple. How do I know it? Because that's the first number on my list vertically. So if I were to do that, I would put a 1 in the 10th place. Why? Because I have 10 tenths and I'm splitting them into 9 equal groups. In fact, I'm going to use some chips that hopefully will help you see what I'm saying. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my goal is to split them into groups of 9. So let's see. Here's a group. There's a group. So now that's 3 groups. 1, 2, 3. That's 6 groups. 1, 2, 3. That's 9 groups. And I had 1 left over. So looking at that, I'm able to put 1 into each of these groups. So I was able to put 1/10 into each of those 9 groups. When I did that, I used a total of 3, 6, 9. So I'm going to use 9. And when you use something, you can't reuse these. So you put them in the group, they're already there. If I have 10 and I remove 9, I'm left with 1. That is the reason why I still have this 1. So now we're going to look at our next place value, which in this case is the hundredths. So we're looking at 1800s. So if I take 1800s and I split them up into 9 groups, let's see. Well, wouldn't you know, I would have 2 in each of these groups. And I would use a total of 18. So that looks like if I take 1 whole and 8 tenths, or I apologize, 1 whole and 8 hundredths, and I split that into 9 groups, I will have 12 hundredths in each group, which matches our model. If you will, go ahead and try number 9. Pause the video at this time and try number 9. Hopefully you've had an opportunity to try number 9. We're going to go ahead and look at that one now. So we have 1 whole, and we know this is 1 whole because it's completely shaded in. And then we have 8 tenths. Well, each group, or I apologize, each line represents 10. Because remember, in that hundredths, 10 of those make 1/10. So we have 1/10, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths. So 1 whole and 8 tenths. 1 whole and 8 tenths. And we're going to split that equally into 6 groups. So this is 1 group, our second group, our third group, our fourth group, our fifth group, and our sixth group. So let's see what's in each of these 6 equal groups. So we have 1, 2, 3 tenths. 1, 2, 3 tenths. Okay, let's look at our third group. 1, 2, 3 tenths. Fourth group. 1, 2, 3 tenths. Fifth group. 1, 2, 3 tenths. And our final last group, our 6th group, 1, 2, 3 tenths. So it looks like if we take 1 and 8 tenths, split it up into 6 equal groups, each group will have 3/10, which is the same value as 30 hundredths if we were to take these and split them into hundredths. So 1 8/10 divided by 6, it has the same value as 3/10. Let's look at the algorithm. So I'm going to have 1 8/10. That is what is being divided. How is it being divided? Our divisor is 6. That's representing our groups. So now let's go through. I personally like to write my multiples of the divisor. So 6, 12, 18. And how am I getting these numbers? I'm adding 6 to itself over and over and over. So 6, 12, 18, 24. 24 plus 6 is 30. 30 plus 6 is 36. 36 plus 6 is 42. 42 plus 6 is 48. 48 plus 6 is 54. 54 plus 6 is 60. And I'm going to stop there because this is the 10th multiple, because any number times 10 gets to move up to the next place value. So looking at this, 6 times 10 is 60. Let me write my multiples, or I apologize, how many would be in each group. If I have 6, there would be 1 in each group. If I had 12, 2 in each group. 18, 3 in each group. 24, 4 in each group. So I'm just writing down how many would be in each group. And the great thing about it is you're really just counting the multiples. So now let's look. I'm going to look at this first number, which is, I apologize, I'm going to look at the divisor. The divisor is a whole number, so we need to make sure that this decimal stays there. So now I'm going to look for one whole. Well, my first multiple is 6, because this is where I'm looking. So if my first multiple is 6, I cannot take one whole and split it into 6 groups. That will not happen. So what I will do is take this one whole and regroup it as 10/10. And since there were 8 tens there, already I have 18, and our model supports this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18 tenths, because each one represents tenths and there are 18 of them. So 18 tenths, I'm going to look. Well, 18 tenths, I can work with that. How many should I put in each group? 3. If I put 3 tenths in each group, I'm going to use all 18 tenths with nothing remaining. So I can see using the algorithm that 1 8/10 split into 6 equal groups will give me 3 tenths in each group. Let's go ahead and look at number 5. So in this one, I'm going to do this a little bit backwards. I'm going to take what problem we have, which is, it's looking like there's some division. Yes, that's great there. Now let's see what is being divided. So I see that there's 10, 20, 30, 1, 2, 3, 4, 5. So this is really 35 hundredths because there's space for 100 and we have 35 shaded in. So 35 out of 100 is 35 hundredths. And we're splitting this or dividing this equally into 1, 2, 3, 4. I apologize. Right here, it just gave it to us. But let's kind of make sure. 1, 2, 3, 4, 5, 6, 7. So that's looking like a 7. Oh, it looks like they're doing 7 groups. So we're looking backwards and we're saying 35 hundredths, 10, 20, 30, 35 hundredths, split into 1, 2, 3, 4, 5, 6, 7. 7 groups. So right here, looking at this algorithm, 3 5/10 divided by 5/10. I'm just going to take this model. We're going to come back to this one, but I'm going to take this model and write what I see. So I see 35 hundredths divided by 7/10. I'm going to rewrite that as 35 hundredths divided by 7/10. My first thing to look for is my divisor. Is it a whole number? Yes, it is. So now I'm going to write my multiples of that whole number. 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. So this is my first multiple, my second multiple, my third, and I'm going to keep writing how many multiples it is off to the side. Because not only is it telling me how many multiples, it's also telling me how many would be in that group. So my decimal comes straight up. Perfect. So now I'm looking for 3. I'm not going to find 3. I wonder why I'm not. I know, because the smallest I can go is 7, and that will give me the ability to have 1 in each group. So I'm going to go as far. I look for 3. That does not work. When it doesn't work, you must show that it doesn't work. If I had 3/10 and I wanted to put it in 7 groups, it wouldn't work. I would have 0 in each group. So I'm going to take those 3/10 and I'm going to regroup them into hundreds. 3 dimes has the same value as 30 pennies. And then I already had 5 there. So now I have 35 pennies. So let me see if I have 35 pennies. Ooh, I could put 5 of those pennies or those hundreds into each group. Okay, and take away the 3,500 that I will use. So that will give me 5 hundredths. Perfect. So that means 35 hundredths divided by 7, 35 hundredths divided by 7 is equal to 5 hundredths. Now, looking at this, I want us to see where this is coming from. And remember, we got 7 for our answer. We're going to come back to that. In fact, I'm going to write 7 here. Didn't mean to put a circle around it. I'm going to write 7 here and put a question mark to see what's going to happen. So let's look at this. We're going to take it this way. 35 hundredths, they wrote it as 3 5/10 divided by 5/10. We're going to rewrite this as algorithm, meaning it's now going to be 3 5/10 divided by 5/10. First thing we're going to do is we're going to look to make sure our divisor is a whole number. Well, wait a minute. It's not. How do we know it's not? Because we can see that there is a digit that is greater than 0 to the right of the decimal. So that lets me know this is not a whole number. So we're going to take this whole number and we're going to multiply it by 10. In 5th grade, hopefully you learned that whenever you multiply by 10, everything gets to move up 1 place value. Well, right now, this is in the 10th place. And if I multiply it by 10, it gets to move up to the 1's place. So I'm going to have 5/10 times 10, which will give me 5 wholes. Well, wait a minute. If you did that with the divisor to keep it equal, you must also do that with the dividend. What is being divided is called the dividend. So if this is the 10th place and this 3 is in the 1's place, 3 will be multiplied by 10 and it gets to move up not from the 1's but to the next place value, which is the 10's. So the 3 is now in the 10's place. And that 5 that was in the 10th place now gets to move up to the 1's place. And that, oh, there's nothing left. So everything has moved up. So looking at this is a great thing about the multiplication fact. So we would go through and write the multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And I know this works because 5 times 10 is 50. My first multiple looks exactly like my last multiple, except it got to move up a place value because it is the 10th one. And everything multiplied by 10 gets to move up a place value. So looking here, we're going to go to our 5. We're going to go down as far as we can. Oh, 7, because 5 times 7 is 35, which also reinforces, hey, that was correct. So to review, if you ever have a division problem where the divisor is not a whole number, multiply until it becomes a whole number. What do I mean? For example, if you have 192 being divided by 2/10, You stop, you look at that divisor. Is it a whole number? It's not. So I need to multiply that times 10. 2/10 times 10, remember from earlier, whenever you multiply by 10, you get to move up a place value. So right now that 2 is in the tens place. If I multiply it by 10, it gets to move up to the ones place. And remember, keeping it equal, fair, equations are equal. If you multiplied your divisor times 10, multiply your dividend times 10 as well. So instead of 192, it would be 1,920, because this 1, which is in the hundreds place, will move up to the thousands. This 9 in the tens place will move up to the hundreds. This 2 in the ones place will move up to the tens. And you can see here, ones, tens, hundreds, thousands. That's it for multiplying and dividing decimals. Please feel free to go through and review this as many times as you need to complete your assignment.